Hello everyone, welcome to a new video class, and in this opportunity we're going to be talking about Git repositories. So let's get to it. So first of all, I just want to acknowledge that a big chunk of the information that I have in this lecture has been inspired by a MIT video lecture that is available in the link on the screen. So Git repositories and Git systems are version control systems. So before we actually talk about Git, let's talk about the generic idea of a version control system. So these systems are, as their name suggests, a way to control the versions that a particular set of files undergo. So in other words, what I'm going to try to do is to keep track of all the changes that a set of files have gone through. And this is going to become very important and very useful in the future when you're working with big systems and you want to know whether a system has been working before and that suddenly it is stopped working at some point. So you can keep track of what changes the code has undergone in the process. The way I call it is the IDA sees everything, because every time a change has been done in the code, a version control system will highlight that and will say, well, this has been changed, so whether you want to create that new snapshot or not. We'll talk about those snapshots in a second. One of the things that I mentioned before is that it helps you to keep track of the history of a set of files. And that set of files could potentially be anything. So I have a friend of mine that actually used it for his cooking recipes, but it could be for anything else. And of course, in our case, it's going to be used to keep track of source code, the source code of whatever application we're writing, whether it is a web application or a Java application or an Android application. It is absolutely irrelevant what type of files they are. It will just keep track of them. Now, there are various type of version control systems. The one that we're going to be using is Git. But there is Mercurial and Subversion as well. So there are other type of version control system, but Git has become the de facto kind of industry standard. So that's the one that we're going to be talking about. Now, what can I do with Git? So I can do a couple of things, but among others, I can keep record of the changes that have been applied or that have been applied to a file or a set of files. In our case, it's going to be our code source or source code, but also it will add some metadata to those records. So it will tell me who was the person that applied the changes, when those changes were applied with date and time, and some sort of description message that the author can include in the record. So if I add a new feature, I can include a method or a message to say the new feature is this, this, and this, and it has been implemented in the files this, this, and this. So it helps you keep better track and better record of the changes that have been done. But the other thing that Git allows you to do, it allows you to create parallel copies of your code. So you can apply changes without compromising parts that are already working. So if you have a piece of code that is working nice, but you want to add a new thing without breaking that, you can create a new copy and add it, and you know that the previous, the original version, it is intact. And it also allows very dynamic team collaboration. So this is very, very relevant in industry because everybody works with Git repositories. So it really facilitates the interaction between developers working in the same project. So this is very typical when somebody is starting to know about GitHub and they're introduced to them. It would be something like, oh, it's great because it helps you collaborate and it has a beautiful tree model kind of theory behind. But then when you try to use it, nobody really knows how they work in the background. They just have a bunch of command line commands that they use without really knowing how they work. So hopefully we have a better idea after this lecture how Git repositories work in the background. So Git uses something that is called graph theory tree models. And I'm not going to go into the maths of this. It's actually quite complex and abstract math, but hopefully we have a good idea of how it works. In short, in a nutshell, Git repositories, what it creates is a series of snapshots. So I can take a picture of all of the files at this moment, and I can take another picture of all of the files at a future moment after some changes have been applied. So we'll see that in a little drawing next. But before, let's see what that looks like. So the first thing is, the files that I want to keep track of could be any kind of directory. And in that directory, I can have some subdirectories, I can have some subfiles. You can see there a sample of a generic kind of directory. I have a root directory, in this case it's called Tom. Tom has some subfolders or subdirectories like data, thesis, or tools, but it also can have some files like, for example, the notes.txt. And then inside each one of the subfolders, you could potentially have some other files or some other files and or subfolders. So this tree structure is, we probably are already familiar with them. But the interesting thing is that once you define that Git has to keep an eye on the Tom directory, Git will keep track of everything that is happening inside that directory. It will keep track of any new file that has been added, any file that has been removed, any file that has been modified, and any directory that has been added, removed, modified, and it just keep track of everything that is happening in that folder. So I've said the word snapshot a couple of times. So a snapshot is exactly what it sounds like. It's just a picture of everything that is in that directory. So we normally will start with an initial snapshot. And in Git terms, we call those snapshots commit. So I can have a commit, and that commit or any snapshot at any time will include always the same thing. It will include the files themselves, and it also includes the metadata associated to that particular snapshot. Like, for example, what time and date that snapshot was taken, who took the snapshot, and what comments were written. So I have that set of files, like the ones that I just showed you before, and that there is a snapshot done already. So there is a commit done already. So the next thing would be, well, I can apply some changes to that code. So suppose that is a piece of work, suppose that is a piece of software that is already working, and I make some changes to that. So once I apply changes to that directory, I can create, if I want, a new commit or a new snapshot. So what is the difference between this snapshot and the previous one? Well, first of all, the files will be different because the files have been modified. So I'm doing a new snapshot in the new state of the file. But it also will include a pointer to the previous snapshot, because I'm going to remember what we said at the beginning. Git is a collection of snapshots that are going to be linked between them. So we'll see this link is exactly what that means. So in the second snapshot, I'm saying, yes, this is what it is now, but just for your reference, that's what it was before. And if I apply other changes, I can keep creating snapshots that are going to be saved to the record or the repository. Up to this point, this is what is called a linear data structure. So I can have a linear data structure that is referring always to the previous state. But one of the things that Git allows you to do is to create what is called a branch. And this is just another like copy of this code that allows you to work on that without affecting the original code. So for example, suppose we have a piece of code that is working it is in production at this moment and it's working fine, but we want to add some new function or some new sort of feature. So we're going to create a new branch, what is called as branching, and I can work on that new feature in that new branch. But it happens that maybe in the production line, some sort of customer or maybe somebody in the support team have been, a bug has been reported and has to be fixed. So when you're fixing a bug, you're going to be fixing the bug on the production branch. You're not going to be fixing the bug in the branch of the new feature because the new feature is not even live. The new feature is something that is in development. So as you can see, the Git structure allows me to have a hierarchy that is not only linear, but that can have depth. It can have multiple branches to allow multiple people working multiple things simultaneously. And at this point, all of this allows you to also have the main branch, which is the one that is in production, uncompromised. It is still intact, unless you want to change it because, for example, there is a bug that has to be fixed. So I can apply for some more changes to my new feature until I have it ready. And eventually, I'm going to want to have a new production line that has not only the new feature, but also all the bugs that have been fixed from previous iteration. So I can create a new snapshot of the code that includes not only the fixed bugs that the bugs that have been fixed before, but also will include the new feature that has been developed in parallel. So in short, this is more or less the way Git works. And what it's going to allow me to do is to keep record of each one of these snapshots. So what happened from here to here? What happened from here to here? What happened in each one of the states of the code? Now, one of the beauties of this is that this record is immutable. So I cannot modify this record. I cannot do changes to this record. And that's one of the things why it's so powerful, because if somebody adds some changes to the code and the changes actually damage the code, well, at least we can go back in time and take a look at who did it, why did it do it, and what happened in that moment. So that doesn't mean that we cannot roll back in time. So if I want to roll back to a previous version, all I need to do is to add a new entry to the tree structure that I have in there that is exactly the same as a previous state. As you can see, that's not getting rid of all these features that happen in here. It's just going back to a previous state saying it was here, but now we decided that the new state is going to be whatever we had before. So what you really are doing is adding a new snapshot to the same timeline, because the record structure is immutable. Now, what is GitHub then? So GitHub is not exactly the same as Git. GitHub is going to be a hosting service for collaborative version control, and it happens to use Git. So GitHub is going to be like a big pool of Git repositories. So you can create your Git repository in your computer, and you can push that to a GitHub repository. We'll see a little diagram in a second that hopefully will help illustrate that. But in other words, what this is going to do is it's going to allow us to do a couple of things. But first of all, it will allow us to have a backup of all the source code that we've written that is up in the cloud. The second thing it's going to allow us is it has a centralized kind of repository for team collaboration. So if you have multiple people working in the same project, they all will refer to the centralized GitHub Git repository. It also works as a catalog for all your code, so you can showcase that in your CV. So if you put your source code from college, for example, in your GitHub account, you can put your GitHub account in your CV, so then your potential employers can see the quality of your code. And also, it works as a repository to access code that is available, that is freely available because it's open source. So if you really want to take a look at the source code of, for example, a Linux operating system, you can go to the Git repository and have a look at the source code if it is publicly available. Also, if it is if it is it's an application that is private, that is privately owned, and the source code is not available, but the owner wants to share that with you, well, they could do that through the GitHub account. Okay, so the next thing that we have to do is let's take a look at how GitHub works from a kind of graphic point of view. So you have whatever repository you have in your local machine, and you can push that to GitHub. And once it is in GitHub, you can pull that from different local machines. So GitHub is going to be like a central repository for Git repositories. It's like a catalog of Git repositories. So GitHub and Git are not exactly the same. Important thing to know is that GitHub uses Git. It's a pool of repositories that use Git as a version control system. Very good. So what we need for this? So we need, first of all, a GitHub account. So you can go to github.com and you can open your free account there. The next thing we need is GitHub Desktop. So there is a link there, desktop.github.com. So you can download there and install GitHub Desktop for you to use. And the next thing that we need is some code or files that we can track using Git. So what we're going to do is we're going to create a project in Nextfins in order to save that to a Git repository. Now, just a quick disclaimer. In the industry, there is a strong presence of Git repositories using the command line interface. What I normally recommend to my students is to start using GitHub Desktop. Now, this GitHub Desktop is a graphic user interface that it is available for Windows, Mac, and Linux, and it works really, really well. It makes the learning curve a little bit less steep, so it is a little bit more user-friendly and a little bit easier to use. So, but in fairness, in the industry, what is used the most is command line. So my recommendation is let's start with GitHub Desktop, which is a graphic user interface. And then if you want to explore command line commands, they're widely available on the internet. Now, there is a video in there on Git repositories that I am linking on the screen. So what we're going to do is we're going to stop this video here, and then we're going to get our hands dirty and do a little bit of a demo of how these Git repositories work, okay? So go and download what you need, create your GitHub account, and I'll see you in the next video.